Well, thank you for joining me. I'm going to look at question 11, and it says a girl is standing a few meters away from a wishing well. So let's put a girl here. She's standing a few meters away from a wishing well, and she throws a coin into the air. Oh, by the way, she throws a coin into the air, and it lands perfectly at the bottom of the well, wherever the bottom of the well is, and 6.5 meters below the ground. Okay, so that's 6.5 meters below the ground. The girl threw the coin from 1.5 meters above the ground, so that is 1.5 meters at that point here. So that's 1.5 meters above the ground, and it struck here 6.5 meters below the ground. At the highest point, it was 4 meters above the ground. So at this point here, it was 4 meters above the ground. And its horizontal velocity was 7.5 meters per second. Calculate speed when it strikes the bottom of the well. Now the speed will have two components. It'll have a horizontal component and a vertical component. And when we know the horizontal and vertical component, the speed will be the hypotenuse, or using Pythagoras, we can get the actual speed. So let's see what we've got. I like putting the two columns. I like putting the vertical component. Let's tighten that. The vertical component and the horizontal component. And UVAST, and let's see what we've got. So we've got our acceleration. Let's say our acceleration is down at negative 9 meters per second squared. So let's go down is negative, and our horizontal acceleration is 0, and our horizontal initial, and it doesn't change. So the whole way it was, if at any point it was 7 meters per second, it was 7 meters per second at every point. So even when it strikes the ground, it's at 7.5 meters per second. So we already know the horizontal component. What we need to do is find the vertical component. And what we do know is that from this highest point, it was 0, to the lowest point, it has dropped 10.5 meters. 4 meters plus 6.5 meters is 10.5 meters. So if we start our vertical velocity at, say, 0 meters per second at the top of the highest point, and we say that it fell negative 10.5 meters from the highest point, 4 meters above the ground, to the bottom of the well, 6.5 meters, we can use our acceleration to find that velocity that it's striking in the vertical component. So V is what we want, and we've got these formulas. V squared equals U squared plus 2AS, and that's the formula that we will use. It doesn't have time in it, but we can get V squared is U squared is 0 plus 2 times negative 9.8 times negative 10.5. So let's put that in the calculator. Let's get the calculator. Where are you, calculator? I'm using my phone, so I'll just type calculator. There it is. All right. So we've got 2 times 9.8 times 10.5, and there's 2 negatives, makes a positive. And so v squared is going to equal 205.8. Now, if we get the square root of that, let's get the square root of 2.1 second. I'll grab my calculator. I had to go to another room and grab the calculator. All right, never mind. Square root of 205.8, and we've got 14.3457, and that is, we'll put the square root of 205.8 meters per second down. Now we can get our speed by using the Pythagoras, so it's 7.5 squared plus 205.8 squared equals our final speed, our S of F squared. So that's 7.5 squared plus square root of 205.8 squared is 205.8. And now that's 262.05 is our square, get the square root of that, and that is our final speed. So the square root of 262.05 and get the square root of that answer, and it is 16.1881879. Did you say decimal place? No. So it strikes the bottom of the well at about 16.188 meters per second. I hope this has helped. Until next time, stay happy. Sorry for taking time to get the calculator.